This is Algebra 2B, Trigonometry Lesson 1, Right Triangle Trigonometry. We're going to start by labeling the three sides of our right triangle. Hopefully we remember this from geometry, but the right angle always points at the longest side of a right triangle, which is called the hypotenuse. Hypotenuse is always the longest side, always across from the right angle. The other two sides of our triangle we're going to label based on their relation to a reference angle. So right now I have angle A marked. I want to mark the other two sides, how they relate to angle A. We have the farthest away side, that is called the opposite from A. And then we have the side right next to A, that is adjacent to A. So adjacent side, opposite is far away, adjacent is right next to it. Now those are both in relation to angle A. I could label these in relation to angle B instead, angle B being way up here. So the opposite from B would be at the bottom versus the adjacent to B would be the side right next to B. So notice the hypotenuse, still the hypotenuse, doesn't change, but the opposite and the adjacent, flippity-floppity, based on if we're talking about angle A or angle B. Next, I'm going to define three trig ratios, sine, cosine, and tangent. We are going to abbreviate sine with SIN. And define the ratio for the sine of an angle to be the length of the side opposite from that angle divided by the length of the hypotenuse. We're going to abbreviate cosine COS, and we're going to define the cosine of an angle to be the length of the side adjacent to that angle divided by the length of the hypotenuse. And finally, tangent, we're going to abbreviate TAN. And we're going to define a tangent to be the length of the side opposite that angle divided by the length of the side adjacent to that angle. SOHCAHTOA is a device to help us remember those ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, SOHCAHTOA. On to a few examples. We're going to start by practicing labeling the sides of the right triangle. We're going to label as opposite, adjacent, and hypotenuse. And I'm going to just write O, A, and H for opposite, adjacent, and hypotenuse rather than write out the whole words. I like to start with the hypotenuse. The right angle always points at the hypotenuse. It's always the longest side of the triangle. I like to do opposite next. I'm going to go farthest away from the marked angle is the opposite. And then whatever's left over, the side that is closest to the angle is the adjacent. Looking at triangle B, it is actually oriented the same way. So the hypotenuse is going to be in the exact same spot. Hypotenuse is still the longest side, still across from the right angle. But now my reference angle moved to the top. I got this Greek letter theta up here. So because my reference angle is at the top, my opposite is now farthest away at the bottom. My adjacent is what is closest to it, the third blank side. Notice H didn't move, but O and A flip-flop based on your reference angle. So triangle C, I'm going to do hypotenuse first again, across from the right angle. The angle that is marked, we go to the opposite side of the triangle, and then the adjacent is the side closest to the triangle. Letter D looks the same again. Hypotenuse is still across from the right angle, but now that my reference angle is on the right, my opposite side is going to be on the left, which makes my adjacent side on the right next to that angle. Letter B, use the triangle at right to give the indicated ratio. So we got those ratios at top. Remember, sine is opposite over adjacent, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we're going to label those sides and then put them into some ratios, also known as fractions, right? So sine, I know, is A over H. I'm just going to write them down here so I can see them a little better. I lied, it's over H. Sine is O over H. cosine is A over H, and tangent is O over A. SOHCAHTOA. So letter A says, what is the sine of theta? Theta's up here in this corner. From theta, I need the opposite, and I need the hypotenuse across from the right angle. So I'm going to put those into my fraction. The sine of theta is equal to the opposite, which I saw by B, over the hypotenuse, which we see as length of C. The sine of theta is B over C. Cosine of phi, a new Greek letter. For cosine, I need adjacent and hypotenuse. So from phi, I'm looking for the adjacent, that's the closest side. The hypotenuse doesn't move, so I only need B over C for adjacent over hypotenuse. Now, if you look at that, the answer for A and the answer for B, they come out to be the same. They're both B over C. That's why sine and cosine are named as such. When you look at the opposite angles in the triangle, they come out to be the same answer. And finally, for letter C, I'm going to go back to blue since I labeled in relation to theta using blue. We need the opposite over the adjacent. Okay, so that's going to be B over A. Opposite from theta is B, adjacent to theta is A. So the tangent of theta is B over A. Letter C, solve each triangle. In this case, that means I'm going to have to get 3 answers for every one of these. I need to get capital A, little b, and little c for this first problem here. And I'm going to start with capital A. We're not actually going to use any of our trig ratios. We're going to think back to geometry. Remember, the 3 angles of a triangle always add up to 180 degrees. And we already have 90 in this corner here. Remember, a right angle is a 90-degree angle. So the missing number for A, all 3 corners have to add up to 180 degrees. So I think I'm going to squeeze him right here. To find A, we're going to do 180 minus 90 minus 55. Okay? 180 minus 90 minus 55. A is 35 degrees. Now to get B and C, we're going to use some of the trig ratios we talked about up top. So I'm going to start by labeling the triangle in relation to my 55-degree angle. We could do this in relation to our 35, but because we already got the 55 on there, I'm going to use that. So I need the hypotenuse, which we know is the longest side of the triangle. We have the opposite from 55, and we have the adjacent to 55. Now, I need to use the 20. I need to use the number to help me find B and C. And I actually have to do 2 problems here, one to get B, one to get C. So to get B, I'm going to be looking at the opposite along with the adjacent. I have to use the 20. So to get B, opposite and adjacent tells me to use tangent. Okay? That's because I have T-O-A, TOA, use tangent. We're going to do tangent of the angle equals, and this is what we were practicing in example B, our ratio is opposite over adjacent. My opposite is B. My adjacent is 20. So I have the tangent of 55 degrees equals B over 20. Now I like to turn this into a proportion. It helps me know if I need to multiply or divide. I can write something over 1 without changing its value. Now I have fraction equal fraction, so I can cross multiply and divide to find the missing value. We're going to start at 20. We're going to cross multiply, divide, and that brings me to my answer. So that is 20 times the tangent of 55. Don't just do 20 times 55. We need the tangent of 55, and that over 1 isn't really necessary because when we divide by 1, it doesn't change anything, but it just helps keep me organized. So on my calculator, you definitely need to be in degree mode, okay? Different calculators have different ways to change their mode. I don't want to be in radian mode. I want to be in degree mode. If you need help figuring out if you're in the right mode or not, just let me know. But I'm going to start then with Did I freeze? There he goes. Okay, so I need 20 times the tangent of 55. I'm in degree mode. I don't really need the divide by 1, but I'm going to throw them in the back, just keep them organized. And that looks like 28.6. I don't have a unit. Don't know if it's centimeters or inches, but we know that the length of B is 28.6. I think I'm going to add an equals A up here. Okay, so I got one more. I need to find little c. Okay, to get little c, again, I have to use adjacent because I need that 20 that I know. And I'm going to try to find c, so I'm looking with adjacent and hypotenuse. So I have to choose sine, cosine, or tangent. I have to choose the trig ratio that works with adjacent and hypotenuse, and that is cosine. The cosine of an angle is equal to the opposite, I lied, adjacent. Adjacent, cosine is adjacent over hypotenuse. Cosine is adjacent over hypotenuse. Again, I'm going to add the over 1. I think it helps keeps things organized so I know what to do. We're going to start with the 20 now. Times 1 divided by cosine 55 equals our answer. 20 times 1 really doesn't do anything, just keeping it organized, divided by the cosine of 55 degrees. And I can go here. 20, don't really need the times 1, you can skip it if you want to, divided by cosine 55 degrees equals 34.9. And that one is done. I do like to check too. I try to label these in order on purpose, small, medium, large, A, B, C. Okay, so if my small side was 20, my medium side was 29-ish, my large side was 35-ish, sounds good to me. If you're getting smaller numbers for your hypotenuse, you know something didn't go right. Letter B. We need to get capital A, capital B, and little b. We're going to start with capital A. We could start with A or B, but if I choose to start with capital A, I'm going to label my triangle in relation to A. So we know the hypotenuse is the longest side. We know the opposite from A is way on the left. The adjacent to A is right next to him on the top. Based on what I have now, to get A, I need two numbers. So I need the opposite and I need the hypotenuse. Opposite and hypotenuse is telling me to use sine. So sine, S-O-H, sine, opposite, hypotenuse. When looking for an angle, we're going to use what's called the inverse. So that's going to have a little -1, and then we're going to put the ratio in the parentheses. So the sine inverse of opposite over hypotenuse. Okay. On my calculator, if you notice the sine, cosine, and tangent buttons, right above them in blue, we have sine inverse, cosine inverse, tangent inverse. So to access those, we're going to hit second sine to get the inverse. Again, angles, inverses. Sine inverse, opposite over hypotenuse, tells me that the angle for sine of A is 26.4 degrees. For angle B, I have two options. I can do another trig inverse, or I could use the 180 rule. If I wanted to do the trig inverse, recognize that from B, this is my adjacent and hypotenuse, so I could do a cosine inverse to get B, because A and H is cosine. Or I could do the 180 rule. If I do 180 minus the 90 I already knew, minus the 26.4, I should get the same answer for both of these. So I'm going to do them both on the calculator just to see. If I do the cosine inverse of 8 over 18, I get 63.6. Or if I take my triangle sum minus my right angle minus angle A that I just found, I should get the same answer, 63.6 degrees. For the third side of the triangle, we could go old school, use the Pythagorean theorem, but I want to practice my trig ratios one more time. Now, I can go off of A, or I can go off of B. I could be doing a cosine with A, or I could do a tangent with A, or I could do a tangent with B, or I could do a sine with B. There's lots of different options as long as you're picking the right numbers to put in the right places. So I'm going to just go cosine with A. The cosine of 26.4 degrees is the adjacent over the hypotenuse. Okay, this is what I was doing on example C part A. Now that I have my cosine equal to my adjacent over my hypotenuse, I can do a cross multiply and divide. So this is going to be 18 times the cosine of 26.4 over 1. That extra divide by 1 isn't really necessary, but we're keeping it organized. Gives us 16.1. And that makes sense if we look at our problem. It should be the medium-sized side, right? Smaller than the hypotenuse, bigger than the short side. He looks good. We have capital A, capital B, and lowercase b. That's it for this video. Good luck on the exercises, and please let me know if you have questions.